Good morning, everybody. Let's see. Okay. I don't know if you can see that. We actually dropped one of Larry's giant boats in the pond outside Oracle. You can sort of see that mast. The mast is higher than our buildings. Okay, so I'm going to talk today about what we're doing at Oracle for around data management, relational, NoSQL, Hadoop. And I thought I'd start off just by answering one of the questions I get asked a lot. It's like, okay, relational database technologies have been around for 40 years. Why is it that it's still going strong after 40 years? In fact, the pace of innovation around relational database has actually been accelerating over the last few years. And if you look at most software technologies out there, they're really exciting for a couple years. There's a lot of hype. A few years later, people sort of figure out what they can do, and then the innovation sort of stops. Relational databases have been different. So let me give you my top 3 reasons about why that's the case. Number one, way back in the 80s, the vendors got together and created a standard. It's called SQL, right? And SQL is not exactly 100% the same from each vendor, but a lot of ISVs have very successfully written applications over the years that work in all the different SQL databases. It gives customers, choice. It lets the customers easily move from one vendor to the other. I think that was a big part of why the SQL and relational databases really got going, really built out a huge ecosystem, and why they're successful today. So that's one thing. And the next thing was developer productivity. Developers can write a couple lines of SQL to join, 10 tables, and that's the equivalent of, tens or 100 lines of code, if you look at all the algorithms used to do those complex parallel joins and all kinds of interesting algorithms. So it's a big developer productivity benefit. And finally, the big thing, which I sort of put on this slide, is if you wrote a SQL application back in the 80s or the 90s, that SQL application continues to work. As we move through all these different computing generations. We went from mainframes and mini computers to client server, the era of the PC, and we had to worry about, minimizing network messages, and we added stored procedures and all kinds of optimizations around networking technologies. And then big SMPs came along, and we had to build databases that could scale up on big SMPs and give you high throughput. And then parallel query technology came along. And so that same SQL statement you wrote before parallelism now could run 100 times faster, once parallel query came along. You didn't have to rewrite that SQL statement. You didn't have to rewrite that application. The internet era came along. We added scale-out technology, our clustering technology, that again let people have huge increases in throughput for both transaction processing and sort of analytics. And then, of course, for the internet, you needed e-commerce support. So you had to have 24/7 availability. So that application you wrote now suddenly was 24/7, highly available. Again, you didn't have to rewrite the thing. And now, sort of, we're coming to this era of big data and the cloud. And again, with relational database technology, customers' applications are sort of the investments are preserved, right? So for the cloud in Oracle 12c, we just introduced multi-tenancy in the database itself. So now if you wrote an application, you can now put it up on a cloud. It's out of the box multi-tenant, perfect for the internet cloud. It's also great for on-premise private clouds. And then the big thing we'll talk about today is big data. We're moving in the era of big data. Everybody wants incredibly high-performance analytics. All the vendors are adding in-memory database technology, column store technology, to make those SQL statements that you wrote 20 years ago, they're going to run 100 times faster again. So, this is the real secret behind relational technology. And it's something that I think in the NoSQL space is going to become very interesting, and we'll talk about that a little later. Okay, so in this age of big data, customers are building their systems out of multiple kinds of databases because their data is being stored in different places. I already talked about relational databases. There's a lot of data in transaction processing systems in Oracle. It's being used to run your business. There's lots of data in big data warehouses, data marts, etc. Customers also now are using Hadoop, especially HDFS, as a data reservoir or a data lake. It's a low-cost, scale-out file system for storing large amounts of data, right? So there's a lot of data now in Hadoop. And then, of course, the subject of this conference is NoSQL. Lots of people are starting to use NoSQL databases. NoSQL databases, are great for putting and getting documents or unstructured values of various sorts. So there's data now going into NoSQL databases. And so what I'm going to talk about a little bit briefly is sort of, for years we've been innovating at Oracle in relational database technology, and now my database team is also innovating in Hadoop and in the NoSQL space as well. So I'm going to give you a brief introduction of sort of what we're doing there, and then we're going to talk about something that I think is really exciting that's going to be an innovation across all three database technologies. Okay, so Oracle has a NoSQL database. We sort of announced it here a year ago. So how many of you actually know Oracle has a NoSQL database? I'm just curious. Raise your hand. Oh, that's pretty good. I think a year ago, no one even knew we had a NoSQL database. So, we have a distributed key value store technology that at its core is using Berkeley DB, which is probably the most popular non-distributed key value store on the market. It's fully open source. You can download it for free. You can use it if you want to for free. You can then, if you want to get support, call us up. We'll sell you a support license by the server using the exact same business model that all the other NoSQL vendors use. We also have a commercial license if you want to use Oracle's standard perpetual license models, and with that you get a little better integration with the Oracle ecosystem kind of thing. On this slide, at some level, all the key value stores are sort of similar. They have, sharding, they have replication. Oracle's key value store is a little different, I think, than others. From the beginning, we've had transactions within the shards. This is based on our Berkeley DB technology. We think transactions are really important, and I just saw on that slide, the trend in the space is to add transactions to the NoSQL systems. Some of the other things we're doing, of course, is we are adding a table model to NoSQL, so you can sort of look at it sort of like a relational table with multiple columns. You can add secondary indexes on different columns, so you can get more flexible querying out of the product. Some of the other things worth adding is we do, I think, a really good job of automatically distributing data. We have a really good elasticity support in the product, etc. And then finally at the bottom, a lot of the reasons customers are using our NoSQL database is that they have other Oracle technologies in the picture, just like I showed you there. There might be an Oracle data warehouse sitting next to a NoSQL database. They want to integrate them together, so they like the fact that they can use Oracle Enterprise Manager to manage across all their databases. They like the fact that there's a single point of support they can get for everything. And we're integrating our NoSQL engine with a lot of other Oracle technologies like coherence, our middleware products, etc. Okay. And so you don't have to take it from me, but this product has, over the last year, started to gain some really good traction. And let me just go over sort of 4 example use cases for the product. So the one on the upper left is a big financial service customer who's doing credit card authorization. They are using Oracle NoSQL database inside sort of the flow of their credit card transaction authorization approval process. You can look at some of the feeds and speeds there, 6,500 operations per second. 85% of the reads are followed by an update, so very update-intensive workload. Manufacturing, big airplane manufacturer is using our NoSQL database as part of their testing process. They have sensors all over their aircraft. All that data is getting loaded into NoSQL in real time. As you mentioned, we have about 750,000 key inserts per second, 6 terabytes of loading per hour. In the telco space, one of the world's largest mobile providers is using an Oracle NoSQL database as part of their mobile personalized advertising system that's about to go live. I don't know if it went live yet or it's about to go live like next week. They have heavily tested the product. They're planning to do about 24,000 operations per second. 100% of the reads are followed by updates. Again, very update intensive. I think it's one of the big distinguishing factors of our NoSQL database. And then finally, there's a gaming vendor who's using our Oracle NoSQL database. 600 concurrent feeds, 400 events per feed, etc. So I think one of the big things you're seeing is Oracle NoSQL Database is not a toy. It's being used in very mission-critical applications for very complex systems, and people are having a lot of success with it. Okay? Just moving quickly to the Hadoop space, we sort of entered the Hadoop market a couple years ago. And Oracle has this thing we call engineered systems. And after we bought Sun, Oracle became more than just a software company. We're a software and a hardware company. And so one of the things we've been doing is we'll take our software, the development group will become like a system integrator, and they will take Oracle's hardware and build out a hardware platform that's optimized for running our different software products. And in the database space, of course, you've probably heard of Exadata. Exadata is our database machine platform that's a highly optimized platform for running Oracle database. Well, the Big Data Appliance is an engineered system that's highly optimized for running Hadoop and the Oracle NoSQL database. It's a scale-out platform of commodity 2-socket Intel servers with 12 disk drives per server. Exactly what people want in this big data and NoSQL space for the platform. We've also, we'll take the standard Cloudera distribution, we embed it on the platform. You don't have to pay for licenses from Cloudera. You get full support from Oracle when you buy the hardware. And we add some doodads. We give you InfiniBand as the high-performance clustering interconnect, so you get some performance benefit. We have something called Perfect Balance. That gives you much improved load balancing in the Hadoop environment. And what else worth mentioning? We've integrated R onto our platform, and we have some integration with the Oracle ecosystem. So high-performance loading from Hadoop into Oracle. We have some SQL technology in there, so you can take Hadoop data and run SQL against it. At moderate performance. And then we've done some engineering around security. All the data you load into Hadoop gets encrypted, and we're participating in the Sentry project as well to improve and beef up Hadoop security. Okay, and as part of this box, as I mentioned before, it's an appliance for either NoSQL database or Hadoop, or both. You can actually install both of them together on the same platform. Okay. So let's quickly move over to the database world. So the first thing I wanted to talk about is just this whole thing about structured and unstructured data. There's a lot of mythology going on out there that, relational databases, they're only for structured data. They only store numbers and dates and columns. Well, that was true, I think, in about 1983. But in the early 90s, of course, all the relational vendors moved from relational to object relational. And when we did that, we added support for all the data types you can possibly want to store in a database. You can store files, which we call lobs in relational terminology. And the performance of files in relational databases are actually better than files just standalone in file systems, and you get transactions on top of that. And then of course, we added rich data type support. We have spatial, we have graph, we have RDF technology embedded in the database. Relational databases don't just store the bits, too. With SQL, you can run queries like, show me all the stores within 5 miles of my current location that have, they're selling shirts that say 49ers on them, and they're size medium or something, right? So you can get this very powerful query across all these different kinds of rich data types. The most recent new addition, which we just shipped a month ago with Oracle Database 12c, is we've added support for JSON in the database itself. So you can store JSON documents in columns of an Oracle database. The columns are schemaless, just like you guys like it. And you can just store them in character string columns, lob columns, binary raw columns, whatever you want. And then the SQL language has actually been extended, so you can extract fields out of your JSON documents from SQL and do sort of the full power of that. And actually, I'm getting ahead of myself, so let me go to the next slide. So this was where I'm supposed to talk about JSON. And so JSON, we have sort of two kinds of APIs. On the left side, we sort of show, developers can get at the JSON through APIs they like. You could use JavaScript APIs. We're building out a Node.js driver for Oracle that'll come out later this year if you want to use that. And we also have REST services into the Oracle database, which is another popular way of getting JSON data out of the database. And then on the right side, we show, if you're a SQL developer, you can also look at the data as a column in a relational table, and you can use extensions to SQL to query on and filter JSON documents via the SQL language. So this just shipped a month ago. And once again, I think the summary is, all the kinds of data that people want to store, whether they're structured or unstructured, you can store all that data in NoSQL databases, you can store it in Hadoop, you can store it in relational databases. There's no distinction. And so this whole mythology about structured and unstructured is all bogus. So if there's anything you guys should all remember when you go home today, it's just forget about this structured, unstructured thing. It makes no sense, right? And, okay, so let's go to the problem statement, right? So we have customers now implementing big data systems, and they've got Oracle data over here, and they now have their Hadoop HDFS, clusters full of data, and they might be using a NoSQL database as well. So what's the problem here? Well, the problem is, how do I integrate this data and actually get analytics back to my business? And I had a big customer who was at our customer visit center yesterday, big ISV. Huge Oracle implementations for their transaction systems and data marts, lots of data in Oracle. And then their developers said, this Hadoop thing is really cool. Let's start putting lots of information also in Hadoop. And so they've been putting petabytes of data in Hadoop as well. And now the business is trying to get information out of the system. And it's like, okay, what do? I try to load all this Hadoop data into Oracle. I have to load like a petabyte, a terabyte an hour. It's, this is impossible. And they're trying to well, maybe if I take the Hadoop data and stick it into HBase, and then from HBase I try to use Hive, maybe I can get something out of that, but then I can't integrate it with my Oracle transaction data. And so they're just going nuts. And so the problem we're having here is that there's so much data that the traditional way of integrating data, which is take all that data and move it into one central place, isn't really working anymore. And what people are trying to figure out is, well, is there some way I can actually get analytics out of this data and integrate across all my data without moving these terabytes of data all around? Okay. So what we think is the answer to the problem, and we think is a growing consensus is, well, maybe we should give SQL access to all these different kind of data sources. And if you look on the left side here, the Hadoop community over the last year has completely jumped on board SQL. SQL went from being, it's that old legacy thing, now it's the coolest thing ever. The Google guys wrote a paper at VLDB about 2 years ago basically saying, we have the smartest computer scientists in the world, but it's still no good. It's too unproductive to write MapReduce-like code. Google doesn't really use Hadoop, but they use something like Hadoop. Our business analysts need SQL. So Google has been writing SQL engines inside their IT, their development organizations. Facebook announced something called Presto. Now they're building a SQL engine for Facebook. They're the biggest Hadoop user in the world. Again, Hadoop wasn't good enough for them. The productivity wasn't there. Hadoop is a batch-oriented environment. It's too slow. So they wanted a high-performance interactive SQL. So they're building a SQL engine. And then all the other guys, Cloudera, Hortonworks, everybody's got their SQL engine they're all building. Now, these are all cool projects, but they're all new, immature products, and they're only trying to work on the problem of running SQL against HDFS data. And as I showed in the last slide, that's not really the problem. That's part of the problem, but not the real problem. On the NoSQL side of the world, you're seeing a lot of the vendors now adding support for what they call table models. Oracle NoSQL database is an example of that. Cassandra is another example of that. Amazon Dynamo. They're trying to make the NoSQL database look like a relational table with rows and columns. And once you do that, SQL isn't that far away either. Okay. And so we think the solution to the problem is give developers the ability to run SQL against all their data from one place. I can write an application, and I should be able to write a SQL statement that integrates and joins data across NoSQL, Hadoop, HDFS, and in this case, Oracle relational database. And that's what I think people are really dying for, and that's what really is going to make these whole big data systems really work. Okay. So I just want to give you a little background on something Oracle did called Exadata. So Exadata is our database machine technology, and Exadata is just incredibly high performance SQL, massively parallel SQL engine. And sort of what was the secret of what made Exadata so fast versus just using conventional off-the-shelf storage and servers? Well, there were three things that I'm going to mention here. The first one is what we call smart scan. So when somebody sends in a SQL statement to the Exadata database machine, we take that SQL and we figure out what are the data sources, and we sort of break it up into fragments where we say, okay, to process this n-way join, we actually have to scan these tables, and here are the filters we have to scan on a table. So for example, a big sales table, find all the rows where the product is, 49er shirt and the color is red or something, right? So we will take that fragment of the SQL statement and we send it right into the storage itself. And so we're pushing the SQL down into the storage nodes, and the storage nodes are doing scans of the data, processing SQL, filtering out the rows that you asked for, right in the storage itself. And the storage has become a massively parallel SQL scan engine, basically. And when it finds the rows of interest, it sends those rows, just those rows, back to the SQL engine on the database servers that complete the joins and everything else going on. Number two is something called storage indexing. I won't talk about exactly what it is, but the basic idea is when you're scanning terabytes or petabytes of data, it's really cool if you can skip a whole bunch of that data because you know the data you want is not there. I'll leave it at that as well, what that works. And caching is another big part of what we do. We actually have something we call the flash cache. So all the data, the petabytes of data, they're all on hard disk, but as the data is accessed, we are bringing that into flash memory so we can do very high performance, basically random IOs against the data using flash technology. Okay, so what are we introducing? So about a month ago, we sort of started talking about something we call Oracle Big Data SQL. So Oracle Big Data SQL, we believe, is the solution to this siloed information problem that we talked about a couple slides ago. We are going to give you massively parallel SQL using standard Oracle SQL dialect that you can run to integrate your data across Oracle databases, Hadoop HDFS, and NoSQL databases, and give you back data with incredibly high performance, just like you get on Exadata, for data that's off Exadata in HDFS or Oracle NoSQL in this case. We can support some interesting things as part of that. Number one, now you can keep the data in place. Those terabytes or even petabytes of data, you don't have to try to move them around to try to get answers out of your data. That data integration problem is gone. You can now get really high performance and just keep the data where it is. Okay, so that's a big deal. This whole data movement thing is gone, right? Number three is a lot of the problems people have with Hadoop in big enterprises are around security. Their auditors and compliance regulations are not happy with the sort of minimal security you get on Hadoop. One of the nice things you get here, if you use the Oracle database query engine, all the security rule technology we have in Oracle can be applied to what looks like Oracle tables in Hadoop and NoSQL databases. Okay, so that's another thing people are really excited about. And as I mentioned on the last slide, all those tricks we use on Exadata are now going to be available on storage nodes running HDFS or NoSQL technologies. Okay. Let's see what else is worth saying here. This is a very open architecture. We are using something called the Hive Storage Handler interface to get at data. So any data that Hive on Hadoop can get at, we can get at. Any NoSQL engine that can run on the Hadoop platform and implements a storage handler, we can actually integrate that information as well. We have our software, again, is running right on the data nodes itself. This is not a federated text system where you're sort of calling all these different engines and getting data and shipping all the data over the network. We are putting our software directly on the data nodes on Hadoop or NoSQL clusters, and we are filtering the data at very high performance right on the data nodes itself. And we only send data that survives, the filtering process, to be integrated with the other systems in the central Oracle database server nodes. Okay? Hope that's clear. Okay, so we think, this is what people really want. They don't want siloed information with huge amounts of big data that they can't integrate together. We think what people want to do is they want to integrate information across relational databases, Hadoop HDFS systems, and NoSQL databases. We think SQL is a great way of doing that. It's a standard interface. You can get really good performance. You can write applications that will be future-proofed over the next, as we go from big data to whatever the next generation of computing technologies will be. And so we're very excited about this. When I mentioned this to this customer yesterday, they were like jumping through the roof. They want it tomorrow. It's something that I think really solves a really important problem in the whole big data space. Okay, so just to summarize what we're doing at Oracle, we're continuing in the relational database side to innovate as we've done over the last few years, 20, 25 years, 30 years. And the innovation is accelerating. Like I said, 12c, the release we shipped a year ago, has multi-tenancy built right into the database. It's a great database for the cloud. And then we just shipped a month ago our in-memory technology that gives you 100 times faster analytic results using in-memory column store technology. So again, we're moving very fast and accelerating that technology. And then we're embracing all the new technologies, Hadoop, JSON, NoSQL technologies. We think those are an important part of the big data ecosystem. We're innovating now in those areas as well. And finally, as we go to the cloud, of course, all the products we're talking about today are going to be available not only on-premise, but also on the cloud as well. And so with that, I think I'm out of time. And thanks for listening.
All right, thanks.